we are discussing our first topic, relations. In the last tutorial, we discussed about the three types of relations: reflexive relation, symmetric relation, and transitive relation. Now you know the definition of reflexive, symmetric, and transitive relation. If a relation is satisfy all the three conditions, that relation is called an equivalence relation. Now we have to do some application-based question related to these three types of relations. Like, let us consider if we have some practical question like, if A is a set X is such that X be a person live in a town at a particular point of time, right? And we have some different relation. First one, R1, first relation, XY, such that X is a wife of Y. This is the relation. And we have to check whether this is reflexive, symmetric, or transitive or not. We have to check the reflexivity, symmetricity, and transitivity for this relation. So, you know that for reflexivity, first one, the reflexivity. Can you say that this relation is reflexive or not? No, this is not a reflexive relation. Because for a reflexive relation, if a person lives in a town, let us see that person is A. So A must belong to the relation. The relation is what? X is the wife of Y. So this not satisfy the reflexive relation. Why? Because X is not a wife of itself. So X cannot be the element of that relation. If we consider, you can say that X or a person, in general we can say that a person cannot be wife of itself. So therefore A not belong to the relation. Since A belong to the relation but A not belong to the relation, a person cannot be wife of itself. So therefore R1 is not a reflexive relation. This is not a reflexive relation, right? Now we have to check the symmetricity. Symmetricity. It is symmetric or not? No, this is not symmetric. Why this is not symmetric? Because since let A is wife of B, then B cannot be wife of A. Since A is a wife of B, so B cannot be wife of A. So AB belong to the relation. Here we can say that since AB belong to the relation, but BA not belong to the relation. So therefore R1 is not symmetric. This is not symmetric relation. R1 is not a symmetric relation. Why? Because if AB belong to the relation but BA not belong to the relation, right? Third part, transitivity. There are two different parts of the transitivity. There are two different parts of the transitivity. In transitive relation, let us consider, let A is a wife of B. There are two parts of the transitive relation. First part, if AB belongs to R and BC belongs to R, then AC must belong to R. First part. And if AB belongs to R and BC not belong to R, that is also transitive relation. Here, if AB belongs to R, we can consider A is a wife of B, but BC cannot belong to R. If A is a wife of B, so B is a male person, B cannot be wife of any other person. So here, we can say that B cannot be wife of any other person. So here AB belongs to the relation R1, but BC not belong to the relation. So this is a transitive relation. Yeah, it is a transitive relation. So therefore R1 is a transitive relation. So therefore R1 is a transitive relation. Because the second element of this order pair cannot be the first element of any other order pair. So we cannot consider AB and BC belong to R. We cannot consider AB and BC belong to R1. So no need to check AC. If AB and BC we can consider, then we have to check the AC. But if AB belong to R, but we cannot take B and some other element. So in that case, that relation is also transitive. So R1 is a transitive relation. So therefore this relation, hence we can say that R1 is transitive, but neither reflexive nor symmetric. Right? It is transitive, but neither reflexive nor symmetric relation. Why? We proved this one, right? In the case of father, if the question is XY such that X is a father of Y, X is a father of Y, in that case this is not a transitive relation. Why? Because if X is a father of Y, if A is a father of Y, Y can be father of Z. Yes, because both are male person. If X is a father of Y and Y is a father of Z, but X cannot be father of Z. Because X is a grandfather of Z. So in that case, the relation cannot be transitive relation. In the case of father, this is not reflexive because A cannot be father of itself, right? A cannot be symmetric. So in the case of XY such that X is a father of Y, this relation is neither reflexive nor symmetric nor transitive in the case of father. In the case of friend, we can say that it is either reflexive, symmetric or transitive. Yes. Some other question we can discuss. XY such that X and Y works at the same place. X and Y works at the same place. So X and X work on the same place. Yes, we can consider this is a reflexive relation. We can say that it is symmetric also, because if X and Y works on the same plane, then Y and X also works on the same place. If X and Y works on the same plane, then Y and X also works on the same place. So it is symmetric relation in that case. X and Y works in the same place. So what about transitivity? If X and Y works in the same place and Y and Z also works on the same place, we can consider X and Y works on the same plane and Y and Z works on the same plane, then X and Z must work on the same plane. So that is also transitive relation. In that case, that relation is an equivalence relation. If the question is XY such that X and Y works on the same place, that relation must be reflexive as well as symmetric, as well as transitive. That relation is called an equivalent relation. Right? That relation is equivalence relation. Now we need to discuss some more questions related to mathematical approach, mathematical examples. Right? Let us see if we have a question, prove that relation R in a set A is equal to x belong to integers such that x lie between 0 and 12 given by, and the first part R is equal to AB such that A minus B is a multiple of 4, and the second part R is such that AB is such that A is equal to B. So first we need to write the sets. First we need to write this set in roster form. Set A can be written as all integers lie between 0 to 12, and 0 and 12 also include 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now this is the set A. Now first part R is equal to AB such that A minus B, mod A minus B is a multiple of 4. Mod A minus B is a multiple of 4. Mod A minus B is a multiple of 4. How can we say that it is reflexive or not? First we have to check the reflexivity. Since mod A minus A is equal to 0 and 0 is a multiple of 4. Is 0 multiple of 4? Or divisible by 4? Yes. Multiple of or divisible by the same thing. 0 is a multiple of 4. So for every number we can say that 0, 0, 0 minus 0, mod 0 minus 0 belong to the relation, 1 minus 1 belong to the relation, 2 minus 2 belong to the relation, and so on. 12 minus 12 also belong to the relation. So therefore R is reflexive relation. R is reflexive relation. First case, right? If the relation is reflexive, so we have to prove by the general example, general statement. If it is not a reflexive, we can take any example. If in any one case this is not reflexive, so we can say that this is not reflexive. But this relation is reflexive in each case. Second one, symmetricity. Symmetricity means what? Let A minus B is a multiple of 4. Let us see, this is 4k. Let A minus B equal to 4k. Let A minus B is a multiple of 4. Then mod B minus A is also the multiple of 4. Same thing. Mod A minus B and mod B minus A both are the same thing. If you consider mod A minus B is a multiple of 4, then mod B minus A must be the multiple of 4. How? Let us see from an example. If we consider mod 1 minus 5, this is the multiple of 4, then mod 5 minus 1 is what? Again multiple of 4. Yes. In this case, if you consider 2 and 10, so 2 minus 10 is 8 in modulus, and 10 minus 3 again 8 in modulus function. Both are the multiple of 4. If you consider the first, you will get the second. So therefore, R is symmetrical. Right? So R is symmetrical. And prove that the relation is an equivalence relation. This is the question. Equivalence relation. It is reflexive, it is symmetric. Now we have to prove this relation is also the transitive relation. Let us see how it is transitive. Very simple. In the transitive relation, we have to consider two things. First one, let mod A minus B the multiple of 4, and let us consider mod B minus C is also the multiple of 4. Mod A minus B the multiple of 4 and mod B minus C the multiple of 4. What do you mean by mod A minus C? This must be the multiple of 4, right? If mod A minus B the multiple of 4 and mod B minus C the multiple of 4, then we have to consider these two things. If you prove this one is also the multiple of 4, then we can say that this is a transitive relation. For example, if you consider mod 1 minus 5 is a multiple of 4, mod 5 minus 9 it is a multiple of 4, then what do we mean by about 1 minus 9? We consider mod 1 minus 5 a multiple of 4 and mod 5 minus 9 multiple of 4. We have to prove 1 minus 9 is also multiple of 4. Yes, this is 8 only. In modulus function, this is also the multiple of 4. Because it's the modulus function, we have to take quality sign only. If these two are the multiple of 4, this is also the multiple of 4. So therefore, we can say that R is transitive. Hence, R is an equivalence relation. Therefore, R is an equivalence relation. Very simple. Now the second part, A is equal to B. A is equal to B. A is equal to A. A belongs to R. A is equal to B. So we can consider 0, 0. Yeah, 0, 0. We can consider 0, 0, 1, 1, 2, 2, 3, 3, up to 12, 12, 12 is equal to 12. Yes, simple. Right? So this is reflexive relation in the second part. Is it symmetric? If A is equal to B, if A is equal to B, B must be equal to A. If A is equal to B, then B must be equal to A. So it is symmetric also. And in the third part, if A is equal to B and B is equal to C, what do you mean by A is equal to C? If A is equal to B and B is equal to C, then A must be equal to C. In the second case, that relation is also transitive. So in the second part, this relation is also an equivalence relation. Why? Because it is reflexive, symmetric, as well as transitive. This is a very important question. Now let's discuss some more questions related to geometry. Like a very simple question. Prove that the relation R, you can see in NCERT book also. Prove that the relation R define the set A of all triangles. Define the set A as all triangle. And the relation R is T1, T2 such that T1 is similar to T2. Is an equivalent relation. Is an equivalence relation Set A is what? Set A is a set of all triangles in a plane. And we have to prove this relation is an equivalence relation. We have to prove this relation is an equivalence relation. This is an equivalence relation, and after that the question is consider three right angle triangle T1 with 3, 4, 5, T2 with 5, 12, 13 and T3 with 6, 8, 10. Which triangles T1, T2 and T3 are related? Which triangles T1, T2 and T3 are related? First we have to prove this is an equivalence relation. Very simple. T1. What do you mean by set A? Set A is a set of all triangles in a plane. So, the relation R for reflexive. First we have to prove for reflexive. What do you mean by reflexive? If T1 is a triangle belong to set A, then T1 is an order pair that must belong to the relation. And what do you mean by T1? What is the relation? Relation is first triangle is similar to the second triangle. So here we can say that a triangle is similar to itself. A triangle is similar to itself. So therefore we can say that T1 belong to the relation. First triangle T1 is similar to the same triangle. You can say that T1 is similar to the T1. So T1 belongs to R. So it is reflexive relation. You can write the statement. You must write the statement here. So this is reflexive relation. Second one, symmetry. It is symmetric or not? Let T1 is similar to T2, then T2 must be similar to T1. Very simple. In symmetry, we have to consider a triangle is similar to the another triangle. A triangle is similar to the another triangle. So second triangle must be similar to the first triangle. Very simple. If T1 is similar to T2, then T2 must be similar to T1. So here T1, T2 belong to R, then T2, T1 also belong to R. So we can say that this is symmetric relation. Now we have to check the third part, that is transitivity. Third part, what? Transitivity. How can we check its transitivity? How can we check its transitivity? We have to check the transitivity for this relation. Is it transitive or not? Yes, this is a transitive relation. Why? Let us consider T1 a triangle which is similar to the second triangle T2 and T2 is similar to the third triangle T3. Then we can say that T1 must be similar to T3. If a triangle is similar to the second triangle and second triangle is similar to the third triangle, so first must be similar to the third triangle. Very simple. If a triangle is similar to this triangle, right? And this is similar to this triangle. If this triangle T1 is similar to T2 and T2 is similar to T3, then T1 must be similar to T3. Very simple. So this is transitive relation. So therefore it is transitive. So it is an equivalence relation. So this is a reflexive, symmetric as well as transitive. So this relation can be written as an equivalence. This is a very important question for 4 marks. Right? Now, the second part of the question is consider 3 right angle triangle 3, 4, 5, 5 to 10, 30, 6, 8, 10. Which triangles are related? What is the relation in this question? What is the relation in this question? Relation is what? Relation is even two triangles are similar. Two triangles are similar. In all the three triangles, first triangle is 3, 4, 5 right triangle triangle. Second right triangle triangle has 5, 12, 13, and third right triangle triangle, that is 6, 8, 10. Are they related? Relation is what? Two triangles must be similar. If these two triangles similar, T1 and T2, let us consider this triangle is T1 and T2 and T3. Is T1 similar to T2? No. Because for similarity, either each corresponding angles are same or the corresponding sides are equal. Here corresponding sides are not equal. The ratio of corresponding side 1:3 and 3:5 not equal. But in the case of first and third triangle, the ratio is same. 3/6, that is 1/2. 4/8, that is, you can also consider this side as 8 and this side as 6, no problem. Now you can say the corresponding side 3/6, 1/2, 4/8, 1/2, 5/10, 1/2. The ratio of corresponding sides are same. The ratio of corresponding sides of first and third triangles are same. So we can say that these triangles are related. Question mark. These triangles are related. So we can say that T1 is related to T3. These triangles are. We can say that since T1 and T3 are similar, and in the question the relation is similarity. Since T1 and T3 are similar, so therefore we can say that T1 is related to T3. The question is which triangles are related. So T1 is related to T3. T2 is not related to any triangle. T2 is not related. T1 is related to T3. Why? Because both are similar triangles. You can also solve the question related to some different question related to the geometry, either congruency or the distance or the cycle. Quadrilateral, you can solve the question related to the geometry in this topic, relation. Very simple. Right? Now, let's discuss some more questions. Let's discuss some important questions in this chapter. Now you can solve the question related to divisibility. We discussed this earlier. A minus b, mod A minus b is divisible by 4. You can also solve the question related to A minus b divisible by 3, 2, 5 and so on. Right? So now let us discuss one more question, like prove that the relation R, prove that the relation R in the set of real numbers, defined as R is equal to AB such that A is less than or equal to B square is neither reflexive nor symmetric and nor transitive. Right? So we have to prove this relation is neither reflexive nor symmetric nor transitive. A is less than or equal to B square. And what is the set here? Set is set of all real numbers. X is such that X belongs to all real numbers. All real numbers. All real numbers, either we can take integral value or fractional value, either positive or negative, no problem. Now, all real numbers. So in the case of all real number, we have to write a real number in which a less than b square not satisfied. This is very simple question because it is given that this is neither reflexive nor symmetric nor transitive. So we have to prove this relation is not reflexive. We have to prove this relation is not reflexive relation, not reflexive. We can take any one example that not satisfies a less than equal to b square. So we can say that this is not reflexive. We can take any example of the real. Let us see. Let 1 by 2 belong to set A. Why? Because 1 by 2 is a real number. And now here 1 by 2 is not less than equal to 1 by 2 whole square. A is less than equal to b square. 1 by 2 is not less than equal to 1 by 2 square, because 1 by 2 is less than equal to 1 by 2 whole square can be written 1 by 4. So this is 0.5 and this is 0.25. 0.5 not less than or equal to 0.25. This is greater than 0.25. So therefore we can say that 1 by 2 is not belong to the relation. So therefore R is not reflexive. You can take any example for this. R is not reflexive, right? You can take any fractional value in proper fraction that not satisfy let A less than equal to b square. Now second, symmetry. Symmetry we will check करनी, right? So now we have to consider any two elements that satisfy the real number. Let -1, 3 belong to set A. We have both the real number, but -1 is less than equal to 3 square. -1 is less than equal to 3 square. Yes or no? Yes. -1 is less than 9. But 3 is less than equal to -1 square. Is it correct? Is it correct? 3 is less than equal to -1 square. 3 is less than equal to 1. Not possible. 3 is not less than 1. So this is not satisfied. -1 is less than equal to 3 square, but 3 is not less than. You can take any example. In that example, first AB must satisfy this relation, but BA not satisfy that relation. You can take any example for this. If for any one pair of real number this not satisfied, so we can say that this is not symmetric relation. So here -1, 3 belong to the relation, but 3 - 1 not belong to the relation. So therefore R is not symmetric. Right? R is not symmetric. Now transitivity. We have to check the transitivity, right? We can consider any three element. We can consider any three elements which belong to the real number, set of real number. This is the set A. And let us see. 2 less than equal to -3 square. Yes or no? Yes. 2 is less than equal to -3 square. And -3 is less than equal to 1 square. Yes or no? 2 is less than equal to 9. 2 is less than 9. -3 is less than 1. -3 is the negative value. This is less than 1. But is 2 less than equal to 1 square? Is 2 less than equal to 1 square? No. 2 is not less than equal to 1. 2 is not less than equal to 1. 2 - 3 satisfy the relation. -3, 1 satisfy the relation. But 2 - 1 not satisfy the relation. For 3 real numbers. So here you can say that 2 - 3 and -3, 1 belong to the relation, but 2, 1 not belong to the relation. So therefore, R is not transitive. So we can say that R is not transitive relation. R is not reflexive, not symmetric, and not transitive. In the case of not, we can take any example which not satisfy the given relation. You can take any example which not satisfy the given relation. You can also solve the question related to A is less than equal to B, or A is less than equal to B cube, or A is less than equal to B to the power 4. These questions are very important from NCERT. A is less than equal to B square. A is less than equal to BQ is also very important. A is less than equal to BQ. You can solve the question related to inequality in any relation. Right? So finally you have to write, hence R is neither reflexive nor symmetric nor transitive. Right? Finally we can say that it is neither reflexive nor symmetric and not transitive. Now you can solve the question related to divisibility, question related to geometry, and the question related to inequality. We discussed one question in each topic related to the relation, right? So now we have to discuss one more question in relation. Do you know about domain and range of the relation? If you convert a relation, if you can change the relation in the roster form, then every first element, that set is called the domain, and every second element of each and every order pairs is called the range, right? So now the question is very important. Let R be the relation XY such that XY belong to natural number and 2x plus y equal to 41. Find the domain and range of R. Find domain and range of R, and also verify whether R is reflexive, symmetric or transitive or not. Whether it is reflexive, symmetric, transitive or not. Right? Whether it is reflexive, symmetric, transitive, first we have to find domain and range. So we can find this relation, we have to write this relation in the roster form. This is set builder form only. Now this is x, y belong to the natural number, and the relation was 2x plus y equal to 41. So we can say that y equal to 41 minus 2x, right? Y equal to 41 minus 2x. If you consider x is 1, you put 1 here, so 41 minus 2 is what? 39. This is the element. Natural number. xy belongs to the natural. We can consider xy 2. If you consider xy 2, 41 minus 4, how much? 37. Right? If you consider this as 3, so 41 minus 6 can be written as 35. 4, 33. Right? 5, 31. 6, 29. 7, 27. 8. If you consider 8 here, so 8 to the 16, and 41 minus 16 is 25. 9, 23. 10, 21, 11, 19, 12, 17, 13, 15, 14, 13. If you consider 14, so 41 minus 28, that becomes 13. Right? Now 15, 11, 16, 9, 17, 7, 18, 5, 19, 3, 21. If you consider 20 as x, 20 to the 4, 40, 41 minus 41. Now you cannot take xi 21. But why? Because if you take xi 21, 41 minus 42 is not a natural number. Here x and y both belong to the natural numbers. So these order pairs satisfy this relation 2x plus y equal to 41. These order pairs satisfy this relation 2x plus y equal to 41. Now we have to find domain and range first. How can you find the domain? The set of the first element of each order pair, that is called the domain. So what are the first element? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 up to 20. This is the domain of this relation. What is the range of this relation? Range is the set of second element 1, 3, 5, 7 and so on 39. 1, 3, 5, 7, 9, 11 and so on up to 39. This is called the range of this relation. Domain means each first element, the set of first element, and range means each second element. Now we have to check the reflexivity, symmetricity and transitivity. Reflexivity. Is this relation reflexive? Is it reflexive? No. Why? Because 1 belongs to the natural number, but 1 will not belong to the relation. 1 will not belong to the relation. Here, you can say that 1 belongs to the set of natural number which is set A, and 1 will not belong to this relation. What is the definition of reflexivity? If A belongs to the set A, then A must belong to the relation. But in this case, 1 not belong to this relation. 2 not belong to the relation. 3 not belong to this relation. That not satisfy this given equation. So therefore, we can say that R is not reflexive. It's not reflexive. Now, for symmetricity. For symmetricity, if 139 is an element of the relation, then 39(1) must be the relation, must be the part of this relation, but that's not correct. If 139 is a part of this relation, but 39(1) is not a part of relation. If 237 is a part of the relation, but 37(2) will not satisfy this relation. If the equation will be x plus y equal to 41, in that case that is symmetric, but here 2x plus y equal to 41, coefficients are different for x and y, so this not satisfy in both the way. If 139 satisfies this relation, then 39(1) cannot be satisfied this relation. So therefore, here we can take any example. Since 139 belongs to the relation, but 39(1) not belong to the relation, so therefore R is not symmetric. R is not symmetric. Very simple. Now we have to check the transitivity. We have to check the transitivity. How can we check this transitivity? Let us see. How can we check the transitivity? Here 14, 13 is a part of relation and 13, 15 is a part of relation. 14, 13, the second element of this order pair, the first element of this order pair. Is 14, 15 is a part of this order pair? No. We have to take any example which fills the transitivity. Here 14, 13 and 13, 15 belong to the relation. 14, 13 and 13, 15 belong to the relation. 14, 15 must belong to the relation. Is it? No. Here 14, 15 not belong to the relation. 14, 15 is not the part of this relation. So therefore R is not transitive. This is not transitive. So therefore we can say that this relation R is neither reflexive nor symmetric nor transitive. This relation is neither reflexive nor symmetric nor transitive, and the domain and range of this relation are these sets. Right? So these are the domain and range. Now you can solve the question related to given equations in any relation. Either the coefficients are same or the coefficients are different. Right? Now we need to do one more question in the relation. One more question. And this is very important question that asked in this year 2015 board exam. Right? Now let n be the set of all natural numbers and R be a relation on n by n defined by AB R CD belongs to AD is equal to BC. For all AB CD belongs to natural number by natural number, so that R is an equivalence relation. Equivalence relation. So that R is an equivalence relation, right? This is very, very important question. So what to mean by AB, R, CD? If the question is A, R, B, means what? What is the meaning of A, R, B? This can be written as AB belongs to the relation. This is the meaning of this. A, R, B. R, this is the first element of the order pair and this is the second element of the order pair. So A, R, B can also be written as AB belongs to the R. So in this case, first we have to simplify this. Now let us see. This relation can be written as R is equal to AB CD, right? Such that order pair ABCD such that AD is equal to BC. What do we mean by AD is equal to BC for every natural number? What do we mean by AD is equal to BC? First multiply last plus is equal to the second multiply third. That means AD is equal to BC, right? In this case. Now we have to prove this is an equivalence relation for natural number to natural number. Let us see. First one, reflexivity. First one, reflexivity. How can we say that this relation is reflexive? Let us consider. AB, or we can say that AB belong to natural number. So these are the natural number. A, P and AB are the natural number, and AB can be written as. What do we mean by AB? Where there is first multiply last is equal to second multiply third. Is it clear in this? Yes. First multiply the last, that is AB, is equal to second multiply the third, that is again BA. Now you know, commutative law is applicable in the product, so AB must be equal to BA here. If you take the same element AB and AB, then AB equal to BA. Why? Because commutative law is applicable in multiplication. So therefore, AB must belong to the relation. Same elements are there. So therefore, R is reflexive. Very simple. R is reflexive. Now we have to prove the symmetricity. It must be the symmetricity. Is it symmetric? Yes. First we have to consider let AB CD belong to the relation. Let AB CD belong to the relation, and we have to prove CD AB also belong to the relation. Let consider AB CD belong to the relation and prove CD AB belong to the relation. Then we can say that this is symmetric. So let us consider AB and CD belong to the relation. So AB CD can be written as AD is equal to BC. AD is equal to BC, right? And if you consider CD AB, then again same thing. First multiply last, that is CB, is equal to third multiply second, that is DA. Is it clear? If AD is equal to BC, then BC must be equal to DC must be equal to DA. If AD is equal to BC, then CB must be equal to DA. Same thing. Both are the same thing, because again commutative law is applicable in the multiplication. When AD is equal to BC, then CB must be equal to DA. So therefore, CDAB also belong to the relation. Therefore, R is symmetric also. Now third and the last one is transitivity. Can we say that it is transitive or not? Transitivity. For transitivity, we have to consider two things. Let us consider AB CD belong to the relation as well as CD EF belong to the relation. Let us consider AB CD belong to the relation and CD EF belong to the relation. We have to prove AB EF belong to the relation. We have to prove AB EF belong to the relation. In this case, we can say that if AB CD belong to the relation, so AD is equal to BC. First multiply last equal to second multiply third. And what do we mean by this? CF is equal to DE. CF is equal to DE. And we have to prove AB EF belong to the relation. What do we mean by AB EF? Here AF is equal to BE. From these two relations, we have to prove this one. Is it possible? With the help of these two equations, we have to prove this equation, then we can say that AB, EF also belong to the relation. So how can we prove this one? AF is equal to BE. Yeah, we can simplify this one. We can simplify it by eliminating some value. Here, we have to eliminate D and C both. Here not D and C and D. We have to eliminate these values. Very simple. We can change this value. So AD is equal to BC and CF is equal to D. C can be written as DE by F. In the place of C, we can write DE by F. We can simplify this one. This relation, by substituting this one, we can write AD is equal to B multiply. What do we mean by C? DE by F. From the second equation, C can be written as, in the place of C, we can write DE by F. Now simplify it. If we cancel D with D and cross multiply, you will get AF equal to BE. This is the relation. So if AB, CD belong to R and CD, EF belong to R, then AB, EF also belong to R. Why? Because with the help of these two equations, we prove this relation that satisfies this one. So therefore, we can say that AB, EF also belong to the relation. So therefore, R is transitive. So finally, we can say that R is an equivalence relation, because we know that the relation is symmetric, transitive, and reflexive, that relation must be called the equivalence relation, right? So this relation is an equivalence relation. So now these are all about the relations. You can solve the question related to relations, right? You can solve the question related to 3 types of relations and check whether a relation is reflexive, symmetric or transitive or not. You can find a domain and range of that relation. The question related to geometry, divisibility, modulus function, equation based question, inequality based question. We can solve these type of question related to relation, right? Now in the next class, in the next tutorial we will discuss the functions. Thank you.